right, so I hope you guys liked that homework take up, and I hope you understand factoring by grouping a little bit more. Before I start any lesson, I always want to refer back to like the orange or salmon sheet with the factoring chart. So just turn to it. Let's see what we have learned so far. We know that factoring is the opposite of expanding. So in grade 9, we were expanding. In grade 10, we learned how to multiply binomials. And all of that was expanding. Now we're going backwards. I'm giving you the answers. I'm asking you what the question was. Last class, we just focused on this section right here. We tried to figure out what the greatest common factor is. And that step is the very first step you do every single time you're factoring. So whenever I give you a question, I'm always going to ask you, what is the greatest common factor? Factor it out, and then let's do the rest of the question. We've also learned how to factor something with 4 terms. So this right here, when you have 4 terms, you're going to do something called factoring by grouping. So here's an example over here, 4x squared plus 8x plus 3xy plus 6y. We just did a bunch of examples like that. I grouped the first 2 terms together and the second 2. I notice here that the greatest common factor is 4x, so I factored it out and I'm left with x plus 2. Over here, I notice the greatest common factor is 3y. I factor that out. And then the next part would be a binomial common factor, and that's our final answer. So we did maybe 2 questions like this. I think you're kind of starting to understand it, which is great. And you should know that whenever you have 4 terms, that is a strategy you're going to be using. Now, what about when you have a question that has 2 terms or 3 terms? Well, like I said, we're going to break them down. We're going to do all of these on a separate date. So today we're going to work on this and we're going to continue it tomorrow. The week we come back, we're going to do this and then we're going to do this. So I'm taking it very slowly. Each one of those categories, I'm spending an entire day so you guys can practice a lot and like keep them separate in your minds, because every one of them has sort of a different rule to follow. Okay, so today we're going to be learning about simple trinomials. I just want to tell you the difference between a simple trinomial and a complex trinomial. First of all, what does the word trinomial mean? How many terms? Oh, I just told you. How many terms do you have when you have a trinomial, right? Good. So whenever you have 3 terms, it's called a trinomial. And those trinomials can be split up into simple and complex. Can you guys tell me what the difference is between these examples and this example here? There's one major difference. And what is it? Say it. One of them has a, I can't quite hear you, but I think you said coefficient, maybe? Because if you did, you're right. Yeah, a simple, any number in front of the x squared, a complex trinomial will always have a number in front of the x squared. A simple trinomial is easier to do. A complex trinomial is a little bit harder. So we're going to focus on a simple trinomial. All of our not have anything in front of the x squared, and we're going to learn how to go from this answer to this question. And all of our factoring is going to result in 2 brackets with binomials in them. Amina? Oh, yeah, that's just the way it's written. Technically, they both have that, but good observation. And I do notice that that's a difference in the way it's written. All right, so turn to the sheet and let's do a bunch of examples. And just like before, keep an open mind. You may not understand it right away. It may be confusing at first, but if you look at the back of that sheet, there are probably 39 questions for you to try. And I promise you, by the 39th question, you will get good at it. Okay. So let's take a look at example number 1, which says x squared minus 8x plus 12. By the way, do you find that this is lighter or brighter than the document camera? Can you see this a little bit better? Okay, good. Yeah, I do feel like it's a little bit brighter. All right. So is this a trinomial? Yes. Is it a simple trinomial? Yes. Why is it a simple trinomial? Safir? Yeah, the number in front of the x squared is just a 1. There's no other number in front of it. Okay, good. So how am I going to trinomial? Remember, this is the question. I mean, this is the answer. I'm asking you, what is the question that gave us this answer? And I'm going to tell you now that whenever we're factoring trinomials, the question that gave us this answer is always going to be in the form of 2 binomials. Samira? Yep, that's it. It's just the one. The rest of the coefficients don't matter. So just to know if it's simple, you're looking at the first term, which is it's a one, it's simple term. The x squared has to be the first term. Yeah. Whenever you're factoring, you guys make sure it's in descending order. So you want x squared, then x, and the constant. If it's jumbled up, make sure you put it correctly. Yeah. What's that? 28th, I think. Okay, so I'm telling you now that when you're factoring a trinomial, the answer is going to result in two brackets. Okay, here's what you do. You look at the very first term and you ask yourself, what two numbers multiply to give a at least I'm signed on. Okay, it's an x and an x. I know. I'm just waiting for it to come up. It's coming. Okay, let's keep going. Now here's what you guys are going to do. So I just want everyone to put your pencils down, look up here, because this is the most important rule. If you can understand this, it'll make a lot of sense. You look at the last number, which is positive 12, and you think of all of the multiply to give you positive 12. So I'm just going to go over to the side over here. Go ahead and tell me all of the numbers or all of the factors. Sorry, you guys online. That's like super frustrating that it keeps doing that. Okay, now what you're going to do is you're going to look at these pairs of numbers and you're going to ask yourself which one of those pairs of numbers can add or subtract to give you that middle term. Okay, so I'm going to walk you through it. But remember, the most important rule, so make sure you're paying attention right now. Okay, so let's go through the first one. 1 and -1 plus 12 won't work. This is never going to be possible, right? So I know that this is it's coming. Yeah, I think we might have to. Yeah. We might just have to because this is just painful. Okay, let's look at 3 and 4. Can we add or subtract 3 and 4 to ever give us -8? No possibility, right? Try it. -3, -4, those won't work. That's -7. +3 minus 4 is -1. We've narrowed it down to 2 and 6, so this has to work. Can we add or subtract 2 and 6 to get -8? Yeah, what can we do? -2 minus 6. What is -2 minus 6? It's going to be -8. And what is -2 times -6. It is 12, exactly. So what is our goal when we're doing a simple trinomial factoring? You're trying to find a pair of numbers that when you multiply them together, that should, by the way, say 6. You're trying to find a pair of numbers that when you multiply them together, it gives you this term here. And when you add or subtract them together, it gives you this middle term here. And there's only going to be one possibility. In this case, our numbers are -2 and -6. Does it matter what order I write them down in? The answer is no. I can write it as -2 and -6, or I could write it as -6 and -2. The order doesn't matter. For checking. Okay, so we've established that our numbers have to be 2 and 6. When we add or subtract them, we get -8. When we multiply them, we get 12. How can we make sure that this is indeed correct? What we can do is we can, and by the way, this is our answer. We can go ahead and check our answer. Because in order for us to check our answer, all we're going to do is we're going to FOIL this like we did earlier this week. And if we can FOIL this and get this original question, then we're right. So practicing FOIL, x times x is x squared. This is going to give me -2x. This will give me -6x. And this will give me +12. And then when I clean up the signs and collect like terms, I'm going to get x squared minus 8x plus 12. Is that what the original question was? Yeah. So our final answer is going to be this one in the dark pink. This is just a check. Like I said, we're going to do this a bunch of times. So if that example was not the most clear, that's okay. Let's try a couple more and see if they make sense. And by the way, the numbers in this case were 2 and 6, and those worked out well. Matisha? Nope, it doesn't matter. The order of those does not matter. Samira?
Like, so like -2x, like this x is like 8x. So we have to like number, it's like 8x, right? So we just forget about the
Question. For the second question, again, x squared plus 8x plus 15. Is this a trinomial? Is it a simple trinomial? Yeah, so I know my answer has to be in the form of 2 brackets. So I'm going to go ahead and put those in. I look at the first term. What are the only 2 numbers or variables that multiply to give you x squared? So we have to make this an x and we have to make this an x. Okay, now what I'm going to do is I'm going to look at this last term over here, +15. And I'm going to ask myself, what are all of the factors of 15? What are all of the numbers that multiply to give me 15? Go ahead and just say them out. 1 times 15, yeah. 3 times 5, is there anything else? No, okay. So that's great. We're only dealing with these 2 pairs of numbers. Now we're going to look at these pairs of numbers and ask ourselves, which one of these can add or subtract to give us +8? Let's look at 1 and 15. Can we ever add or subtract 1 and 15 to give us 8 ever? No, we can try like adding, subtracting. It's not going to work. 3 and 5, can we add or subtract those to give us +8? And what would those be? Yeah, +3 plus 5 is going to give me +8. And then what's +3 times +5? It's +15. So that seems to be our answer. I don't know why I erased that. Let's go ahead and put the numbers in. Doesn't matter if the order, so I'm going to go ahead and put +3 here and +5 here. This is factoring. It's the opposite of distributive. So remember, in the beginning of this week, we learned how to FOIL this. Now I give you the answer and I'm asking you what the question is. 1 second. Let's check our work. And to check our work, we're going to refoil it. So I'm going to write the word check. I think I have an answer, but I want to make sure it's correct. And I'm going to FOIL it. So x times x is x squared. X times +5 is +5x. 3 times x is +3x. +3 times 5 is +15. And then let's clean up and collect those like terms. Do we get the original question back? Yes, we do. So we're correct. Let's take a look at question number 1 in the second section. We have 3x squared plus 3x minus 18. Is this a trinomial? Yes. However,
Is this a simple trinomial? No, how come? There is a number in front of the x squared, so we run into a problem. We do have a solution for this. Remember how in yesterday's class, we were taking out a greatest common factor? Take a look at all the terms in this question. Is there a greatest common factor in this question? Say it. Yeah, it's the number 3. So we're going to begin this question by taking out the greatest common factor, which is going to be the number 3. If I take out the question number 3, what am I left with? Yep. Yep. -6. Okay, so 3 times x squared is 3x squared. 3 times x is 3x. 3 times -6 is -18. You guys, when we are going to factor this, if you've taken out a 3, you can kind of ignore it. You don't have to worry about it anymore. It's just there. We're going to be factoring only what is inside of this bracket. So that's another rule. If you've taken out a greatest common factor, that's great. You just leave it as is, like I've written it there. When I'm factoring, I'm only going to be looking at what's inside of the bracket. And the thing inside the bracket, is that a simple trinomial? Yeah, so now we know how to do this. So this is our third example. Let's see if we can do it a little bit faster this time. What 2 numbers multiply to give us x squared? We know it's going to be an x, and we know it's going to be an x. Let's look at all of the factors of 6. So what are all of the pairs of numbers that multiply to give me 6? Safir?
2 and 3, 1 and 6.
Yep, and I think that's about it. 1 and 6 and 2 and 3. So I look at this number and I ask myself, what numbers multiply to, I don't worry about the signs. The signs we can figure out later. I just look at the number. I say 1 times 6 is 6, 2 times 3 is 6. Perfect. Okay. Can I add or subtract any one of these pairs of numbers to give me a positive 1? Jennifer, what do you think? Perfect. 1 and 6 will never work because they never add up to positive 1. However, -2 and positive 3 do work because you can put -2 plus 3, that adds up to give you positive 1. And does -2 times positive 3 multiply to give you -6? So those numbers do work out. So again, a pair of numbers where when you add them together, you get the middle term. And when you multiply them together, you get that last term. Keep telling yourself that. Does it matter what order I put these in? Not really. You can put it in any order. You could put a positive 3 here and -2 there, or -2 and positive 3. Go ahead and, so this is our final answer. Now go ahead and write down the word check and redistribute it and see if you can get it to work to FOIL. Samira?
So when it multiplies to give you 6,
Mm-hmm.
what does that tell you again?
It tells you that you've done the right thing. So you're finding a pair of numbers, like we found -2 and positive 3. It should multiply to give you -6, and these numbers should add and subtract to give you positive 1. Don't worry about the x, just look at the coefficient.
So it's supposed to add to give you the middle term, and it's supposed to
Multiply to give you the last term. Correct, yeah. I'm going to run out of space, but hopefully you guys can finish this question off without.
And like the 2 numbers that give you the like middle and last term,
Yeah.
that's what you're putting in.
Yep, exactly. Yep. So I ended up getting the right, I ended up getting the original question again. Did you guys also get the original question? Okay, great.
So wait, do we have to leave 3 on the left side?
You have to leave 3 on the outside, yes. All right, go ahead. All right, so what was the first step in doing this question? What did you guys do? Is this a simple trinomial? No. So what can we do to maybe make it a simple trinomial? Jordan?
So you're gonna find
Good. And what are you left with when you do that? Minus 6x plus 8. Excellent. So hopefully everyone's first step was to take out the greatest common factor, which is the number 4, and see what you're left with. Now, for the next step, we're going to keep the 4 outside, and we're going to make 2 brackets because every trinomial will factor into 2 binomials. And I'm going to look at the number 8. What are all the factors of 8? 1 times 8, 2 times 4, and that's it. So these are the numbers that multiply to give you 8. Do any pair of these numbers add or subtract to give you negative 6? Negative 2 minus 4. Good. So basically, negative 2 minus 4 is negative 6, and negative 2 times negative 4 is positive 8. That has to be our solution. Doesn't matter what order we put it in. It's, oh, I forgot to put my x's. So there's going to be an x here and an x here. Then I'm going to put in a negative 2 here and a negative 4 here. One thing I did notice as I was walking around, and I guess I should have mentioned this, this is your final answer. This is the answer to the question. If you want to check your work, make sure you very clearly write down the word check and then show me that you're checking it. If you just get this answer and then start foiling it again, you're going to lose marks because you've actually you've factored and then you've gone backwards and expanded it again, and then you're just going in a big circle. It's fine if you want to expand it again to check your work, but make sure you write down check and then that you're checking your work. I'm going to not check this. Did anyone check it and notice that this was the right answer? Okay, great. Last 2 examples. No, I want to finish the last 2 examples because after we come back, I just want to, we'll do the challenge after we come back. You guys, the last 2 examples, what do you notice is different? Like what's something in this question we haven't seen in the other 4? Angelique? Yeah, they have 2 variables. See how they have an x and a y? Don't let that confuse you. Don't let that scare you. I would even say ignore the second variable. Do the question exactly as we have been before. There's really nothing different about it. Okay, what 2 numbers multiply to give me x squared? Times. Good. Okay, let's look at the number 15. The factors of 15 are 1 and 15 and 5 and 3. Which one of these pairs of numbers adds or subtracts to give me negative 2? Angelique? 5 minus 3 is close, but that would only give me a 2. How do I get a negative 2, Nirmatha? Close. If you did negative 5 minus 3, you get negative 8 plus 3, exactly. Negative 5 plus 3 is going to give me negative 2. Negative 5 times positive 3 is going to give me negative 15. So those are definitely our answers. I'm going to put a negative 5 here and a positive 3 here. But now, how do I make that last number equal 15y squared? What do I have to add to the very last number here? Yeah, you just have to add a y and a y. And that's why I said don't even worry about the extra variables. All it means is you're basically just going to add an extra letter to your last two terms. Okay, last example before we do go on our break. Go ahead and try question number 2 yourselves. Samir? Okay, so for this question, let's get a nice color to cheer us up a little bit. There we go. I don't have a common factor. If there was a common factor, you would have taken it out. What 2 numbers multiply to give you c squared? C and c. What are the only 2 numbers that multiply to give you 2? Yeah, and so if the only pair of numbers is 2 and 1, how can I add or subtract these to get negative 1? Yeah, negative 2 plus 1. So I'm going to write down negative 2 here, plus 1 here. And then how do I make that last term a d squared? I'm just going to add the letter d here and the letter d there, and then that is your final answer. When we come back from our break, I do want to do a challenge question because you will see this on your sheet. And then, like I said, we're then going to be working on handout C. We're going to have quite a bit of time, like 50 minutes. And I'm hoping that as a class, we can get to at least question number 20 before you leave for home today. So let's take I'm just going to pause the recording. So I have included a challenge question at the end. And the reason I included this challenge question, is that someone from our class maybe? We'll just wait. The reason why I included this challenge question is because you will find a couple of them on your sheet. Sorry, Francine, do you mind getting that? It might be someone in our actual class. How would you do a question like this? Take a look at it. It's a minus b squared minus 4a minus b minus 12. And at first, it looks very confusing because there's a lot of stuff going on. But to do a question like this, we are going to, I'm recording too. We are going to be substituting another value for the a minus b. So to begin this question, I'm going to say let maybe the letter x equal a minus b. Okay, so I recommend you do this anytime you see a question where there's a binomial, it looks very complicated. I don't want you to expand this. I don't want you to redistribute or anything like that. I just want you to recognize that there's an a minus b here and here. I'm going to replace it with an x. So when I do that and I rewrite it, this is what I end up getting. I'll end up getting x squared, because this a minus b is replaced with an x, minus 4x minus 12. Does that make sense? Does everyone see what I did there and how I replace it? What is the point of me doing that? What have I essentially done now? Yeah. Yes, exactly. So if you recognize that these complicated binomials, when you replace them, it's just a simple trinomial, the question is so much easier. Okay, so let's solve this. Simple trinomial. So I'm going to put an x here and an x here. Can you think of two numbers that multiply to give you 12, but add or subtract to give you 4? Yep, negative 6 plus 2. And as you get better at these questions, you can will probably be able to do it in your head. You won't have to write down all the factors. If you wanted to write down the factors, that's totally fine. It's 1 and 12, 3 and 4, 6 and 2. And you basically go through each pair. 1 and 12 will never add to give you 4. 3 and 4 will never add to give you a negative 4. However, 6 and 2 will if you put negative 6 plus 2. Okay, we're not quite done. We have factored this, but we can't just leave the x's in there because the original question did not have any x's. So what are we going to do now? Hamangi? Yeah, we're going to bring back the a minus b. So inside the bracket, wherever I have an x, I'm going to put a minus b minus 6. And then wherever I have an x here, I'm going to put a minus b plus 2. And that is my final answer. So although I wrote challenge, it's not that tricky once you see how to do it. Okay, here's what we're going to be doing now for the next 40 minutes. Handout C is going to be your homework. Please make sure you complete all of it by tonight, because in tomorrow's class, when we meet again, we're going to do the same thing we did today. I'll give you the whiteboards. We'll maybe pick 5 or 6 questions. We'll take them up. I just want to highlight a few of them. So questions up till question 37. So 37, 38, and 39. These ones are the quote unquote challenge questions. So you're going to do these in the same way we did that very last question. Okay, so if you just want to circle them or highlight them or something, just know 37, 38, and 39, you're going to do them the way we did the last question. Everything else is a simple trinomial. Make sure you first take out a greatest common factor. Some of them are tricky, like question 22 might be tricky. Maybe question 36 might be tricky. And those are the ones we'll take up tomorrow.